Automobiles are part of urban life. Every class of people, irrespective of gender and age, use automotives for almost all kinds of trips. Unlike other nations, India, with its narrow roads, heterogeneous traffic and poorly disciplined driving, make efficiently controlling the road traffic difficult. The closely spaced and poorly designed traffic junctions make the situation more chaotic. These road intersections warrant for controlling the traffic to avoid conflicts, deadlocks, and safe crossing of pedestrians. Most of the traffic signal controllers are fixed-time controllers. They operate on statistical data stored in timetable, but fail to respond to the real-time traffic demand, resulting in other issues like wasted green time and unresolved queues. Often the green signal is shown to the roads where there are no vehicles and the needy are stopped unnecessarily. The wasted green contributes to increased junction delay and travel time. The unnecessary waiting makes the drivers frustrated, tempting them to jump the red. C-DAC, Center for Development of Advanced Computing, Thiruvananthapuram, is a premier R&D center of the Department of Electronics and Information Technology under the Ministry of Communications and Information Technology, Government of India. It is a national center of excellence. Founding Padam 8000, India's first supercomputer, is on the top of achievement history of C-DAC. C-DAC introduces an effective and economical solution to replace conventional cabled traffic control system to ease the hassle of signal installation and to effectively control the traffic junction with vehicle-actuated signal operation. WiTraC, the vehicle-actuated wireless traffic control system, is the first of its kind in the country with many novel features. WiTraC is made to respond to the fluctuating traffic by assessing the real-time demand. WiTraC uses a video image processing to detect the presence or passage of a vehicle at a traffic junction. However, the vehicle detector interface is universal to accept signals from above the ground and inductive loop detectors. In video image processing, cameras are focused at the stop line and detection zones are marked in the field of view. The detection zones are called virtual loops. When a vehicle crosses the virtual loop, the system identifies the presence of a vehicle demanding a green signal or requests extension of a green signal. The major parts of WiTraC are master controller, slave controller, radio modem. The major advantages of WiTraC reflects in the signal installation.
WiTraC के जैसे ये TOT हमने ली थी, उसके बाद जब इसको हमने देखा और इसको हमने एक तो इसकी इंस्टॉलेशन बहुत आसान है। सड़क पे हम जब रोड्स पे जंक्शन पे डेवलपमेंट कोई नया जंक्शन करते हैं तो जंक्शन पे हमको एक रोड कटिंग की मेन प्रॉब्लम आती है जो बिटुमन को हम काटने के लिए डिपार्टमेंट एग्री नहीं होता है, जिसकी वजह से मेन फैसिलिटी हमको इससे मिली कि भाई हमको 3 दिन में इसको इंस्टॉल करके हम WiTraC को स्टार्ट कर सकते हैं जंक्शन को। और दूसरा जो दूसरे कंट्रोलर का जो सिस्टम होता था जिसमें डिगिंग पिट करा करते थे और कंट्रोलर लगाते थे, पोल खड़े करते थे, केबलिंग करते थे, वो एटलीस्ट 10 से 15 दिन लग जाते थे जंक्शन लगाने में।
WiTraC also helps safe crossing of pedestrians by demand.
It is found that the cost of a WiTraC system is also comparatively lower than a conventional system because there is a lot of savings in terms of the cost of digging, the resurfacing, the cost of pipes, ducting, etc.
One of the key principles of a BRT system is to enhance the movement of the bus through junctions. The camera-based vehicle actuation actually helps the BRT movement as well. So one of the experiments that we did here on MR9 junction along the corridor, there we have got about 3.6 seconds average waiting time for the bus at the junctions, which is a remarkable improvement from previous conditions where a bus would have to wait from anywhere between 100 to 180 seconds before it gets green.
In a city traffic network where junctions are placed in close proximity, good chances are there for stopping of vehicles at every successive traffic junction. This causes increased stopped delay, contributing to higher travel time, unnecessary fuel consumption, increased pollution, and driver frustration. The stopped delay at traffic junctions can be reduced drastically by coordinating the green signals of adjacent junctions in selected corridors. By signal coordination, the vehicles entering the corridor in green signal is allowed to move along the corridor without stoppage. Every successive junction will open green signal for the vehicles approaching from the previous junction at a specified speed. Systems that can adapt to the randomly varying traffic only can coordinate signals effectively and deliver better travel time and reduced delay. To address this issue, C-DAC developed an adaptive traffic control system and control algorithm, the Composite Signal Control Strategy, otherwise known as CoSiCoSt. The adaptive traffic control system consists of traffic signal controllers, vehicle detectors, communication network, central control and monitoring station, and the control algorithm and application software. The vehicle detectors deployed at every approach of a junction report the traffic demand to the corresponding traffic signal controller. The traffic signal controller pre-processes the traffic information and adjusts the signal timing according to the traffic demand. This information is sent to the central control and monitoring station. The central control and monitoring station collects similar information from all traffic junctions in the network. The control algorithm, CoSiCoSt, evaluates the signal timings required for each junction in the network and computes the network signal timings for minimum stops and delay. These timings are sent back to the corresponding intersections for execution.
कैमरे लगने के बाद जेलन मार्ग या कहीं भी कैमरे लगे हैं, वहाँ ट्रैफिक सिग्नल बहुत हुआ। अब जो लोग पहले जल्दी भगते थे या ट्रैफिक सिग्नलों का उल्लंघन करते थे, वो उल्लंघन बहुत कम हुआ है। उससे एक्सीडेंट भी घटनाएं कम होने लगी है। लोग आराम से, क्योंकि उसको इंतज़ार कम करना पड़ता है और टाइम से वो पहुँच जाते हैं, इसलिए इससे एक्सीडेंट की घटनाएं कम हो रही है। दूसरा, ट्रैफिक सिग्नल जो हमें बड़ी मेहनत करनी पड़ती थी ट्रैफिक निकालने को, वो भी अब कम हो गई है।
ATCS सिस्टम के द्वारा काफ़ी अच्छा सुधार देखने को मिला है जयपुर में, और सिंक्रोनाइज्ड ट्रैफिक मिलता है, कहीं जाम नहीं लगता है चौराहे पर, और रियल टाइम के अनुसार सिग्नल चेंज होते हैं।
CoSiCoSt has inbuilt filters, methods and techniques to address the high heterogeneity and poor lane discipline prevailing on our roads. This method bears an Indian patent owned by C-DAC and the Department of Electronics and Information Technology, Government of India. Pilot implementation of CoSiCoSt at Pune, Maharashtra improved the average travel speed up to 12% and reduced the average delay up to 30% on selected corridors, with the projected savings on fuel and travel cost to rupees 5.6 crores. CoSiCoSt has eased the traffic congestion on the Jawaharlal Nehru Marg in Jaipur, Rajasthan.
C-DAC जो पहले फर्स्ट फेज और सेकंड फेज के अंदर हमने MI रोड करवाया, उसके काफ़ी अच्छे रिजल्ट्स आए। वो इसके लिए यादगार में एक कंट्रोल रूम बना हुआ है जिसमें पुलिस को काफ़ी कुछ सहायता मिली। उसी को ध्यान में रखते हुए हमने JLN के अंदर एडॉप्ट करके अभी हाल ही में इंस्टॉल किए हैं और JLN के अंदर काफ़ी अच्छी परफॉर्मेंस दे रहे हैं।
Design and development of all the solutions coming out of C-DAC lab are guided and monitored by expert committees constituted by the Department of Electronics and Information Technology, Government of India. Government of India holds the IPR of such products, offering better confidence to the customer. Roads are the nerves of any country's development. It's a public place where people need to spend their valuable time. Effective use of roads is important for the safety of the public and the prosperity of the country. With WiTraC and CoSiCoSt, let's together make our planet Earth a better place to live in.